There are two ways to implement virtualization. The first one is the traditional virtual machine based hypervisors. The second one is more advanced where we use containers. If you are a techie or work in IT or telecom or network domain, this becomes utmost necessary for you to understand this virtualization technology, as every one of us, from large scale mobile operator to the giants like Google and Amazon, are going to build services to support virtualization. Here we'll cover the high level concept of hypervisor based virtual machines and containers, which are easy to remember for a lifetime. Container is based on an advanced technology and provide effective alternative for the virtual machines running on hypervisors. Just like we use physical container to move things or goods from one place to another, a container sitting on a top of ship moves from one destination to another, one country to another. Similarly, the containers which we are going to use in virtualization world, they are going to help us in running the application reliably when moved from one computing environment to the another one. This could be from the developer laptop in a lab or in a test environment, from the staging environment, from the production environment, to the physical machines, to the data centers, to the virtual machines in private and public cloud. Let's start our journey to understand the hypervisor and containers. In previous video, we have covered the need of cloud networks and cloud computing. We have also covered the concept of SDN and NFV. Now we are going to cover another aspect of virtualization, where we will go deep in understanding what is virtual machine, what is hypervisor, what is container, what is Docker, and how this technology work. VM or virtual machine or containers are going to do the same thing, that is virtualization. Their goals are absolutely same. They are going to enable applications to use virtual resources such as virtual hardware, virtual compute, virtual network, and they do it in a much more scalable and a flexible way. With virtualization, there is no need for physical hardware. Well, you don't need the physical hardware. The computing resources are available on the cloud. Then it gives you a lot of effectiveness in terms of the power, space, infra, and cost. The main difference between the container and VM is in their architectural approach. With times, things have changed a lot. Virtualization is one of these innovative technologies that was invented somewhere around 1960 by IBM. Since its inception, the virtualization technology have helped transform the way people compute and they process the information. In today's world, this virtualization technology is used to logically separate the physical resources on a server and use them as a different isolated machines. We call them as virtual machines. The CPU becomes many virtual CPUs, the storage becomes many virtual storages, the RAM and rest of the network resources will become the virtual network and virtual memories. Well, this is a complete world of virtual network resources which are available to us in a very discrete, in an isolated way. What are virtual machines or VM? How this hypervisor works? Gone are the days when we are running one application on one server. And by physical server, I mean the hardware just like the one you are seeing on the left hand side. It's a bare machine. It's a basic computing machine. This type of deployment requires new server every time we want to have a new application or new service. The problem with this traditional deployment is fairly simple. Like most of these servers, they are underutilized. So typically they are running on 10%, 20% and rest 80% is wasted. Any new requirement takes multiple days, multiple months, as this requires new server procurement, arrangement, deployment and all of that stuff. That takes a lot of time and the business needs this to be fulfilled like yesterday. There is always an issue with the flexibility, as traditional model is dependent upon underlying hardware specific variables and environment to function properly. Well, now understand how hypervisor helps us. How this virtualization helps and this works on the ground. Well, on right hand side you can see this new thing as a virtual machine, which is telling us with help of hypervisor we are running multiple applications on top of the core hardware and hypervisor layer. As VM or virtual machine is essentially an emulation of the real computer that executes the program like a real computer down the line, VMs or virtual machines, they run on top of physical machine using a hypervisor. Now let's go deep in the virtualization and the concepts. Virtualization is act of migrating the physical system into the virtual environment. You can see it out there. App 1 is running on a traditional network on left hand side, which gets virtualized down the line on the right hand side. In other words, virtualization is a creation of a virtual resource by abstracting the actual hardware resources. Here we have virtualized the computing resources, which allow us to use one server for multiple applications. And here we are creating the isolated environment for these individual virtualized applications. Here resources are abstracted as a virtual compute, virtual storage, virtual network. The abstraction means a software emulation of the hardware. The apps are only interacting with the guest operating system and they are using the virtual resources instead of a physical hardware. With help of virtualization, we can instantly access nearly limitless computing resources, which allows for faster and flexible rollout of the business requirements. With virtualization, we can improve overall application performance, we can do a better scalability, we can improve a better utilization of our resources, and it's all helping our business to launch the new applications, the new services on the fly as and when they are required. Now let's understand what is the role of hypervisor and how it works down the line. Now we know that virtualization and we know how virtual machine works. Let's understand the deep concepts of the hypervisor. Hypervisor is basically a building block for hosting the applications for virtual machine. The role of hypervisor is to take resources from the physical computers. Further, these resources are emulated and abstracted as a software, and they are provided to the virtual machines in the form of virtual compute, virtual storage, virtual network, like that. One VM or virtual machine can consume resources allocated which are meant for that particular virtual machine only. It cannot consume resources of other virtual machines. It cannot consume resources which are not allocated to that particular virtual machine. Hypervisor isolates and protects these virtual machines from eating up each other resources. In case one VM exhausts all of its resources, it is not allowed to eat up the resources of other VM. The hypervisor runs on host machine using a host operating system. You can see this host operating system on the screen. Now, this particular hypervisor hosts the multiple virtual machines or VMs. And these multiple VMs, they run as a guest machines. The guest machine or VM contains their own operating system. Like the operating system of guest machine can be Windows, can be Mac, can be Linux. It can be different from the actual host operating system. So it also requires the VM also host the application and the supporting libraries. So the application in order to run also requires couple of libraries and the dependency. So a virtual machine is a combination of a guest operating system plus couple of libraries, then the application piece. The features and roles of hypervisor are absolutely clear. Hypervisor is a software component. Hypervisor works on host machine using host operating system. Hypervisor is a key to enable virtualization. Hypervisor distributes host hardware resources. Hypervisor provides isolation between the guest machines or virtual machines. With protection provided by hypervisor, one guest machine cannot affect the host or cannot affect any other guest machine. Now let's start our journey of containers and Dockers. The giant ship, you can see it on the screen. This is where we can see our containers, the physical containers which are sitting on top of the ship, and a docker which is sitting on top of these containers. Basically, that's a crane which is moving these containers here and there. Before we get into the deep understanding of container, let's understand why we call container as container. You can see these physical containers on the screen. There are few very great qualities of these physical containers which we are going to reuse in a virtualization world. Let's discuss the similarities between the physical container and a virtual container. The containers are a complete package. They contain both application and respective libraries and all other dependencies. These containers are then shipped as a one package from one machine, from one computing environment to another computing environment, and it is being ensured that they will run in a very fault-free manner wherever they are supposed to run. You can run it in a laboratory, you can run it on a developer machine, you can run in a public cloud or a private cloud. They will run exactly same. So that is the protection and the portability which is provided by the container. Now let's go inside the depth and let's understand the similarities in a detailed way. The first quality of a physical container on a ship is a standardization. A physical container is the same physical container worldwide. You consider a container from a USA or you consider a container from India or Japan or China, it looks like same, the dimensions are almost same. The looks and physical characteristics of containers are always same everywhere. In technical world, the virtualized containers which we are going to discuss, they have evolved as a new standard for doing the virtualization. They are standard everywhere. The second quality of a physical container which is sitting out there on a ship is a portability. The physical containers are highly portable. They can be shipped from one country to another country. Similarly, in virtualization, the virtual containers which we are going to discuss, they are very portable. They are running in the same way as they are running in a production. They will run in the same way in a actual production environment, in a public cloud, in a private cloud, anywhere, everywhere. They will run exactly in the same way, and they are very portable. The third quality of a physical container is the lightweight. The container which is sitting out there on a ship, it's very lightweight. It's easy to install, it's easy to remove. The virtualized container are also very light. They share the machine operating system kernel and therefore don't require a new guest operating system. That drives a lot of efficiency, and you can fire a container on the fly. You can boot a container, you can kill a container, you can install a container, you can do whatever task you want to do with the virtualized container, and that happens within few seconds. With hypervisor, probably you need to wait for a few minutes, and in couple of scenarios it takes a lot of time to boot up and to come up on the screen. The fourth quality of physical container is security and protection. Just like goods, the physical goods are safe in a physical container, applications in our virtualized container, they are also safe. The Docker provides us strongest default isolation capacities and the capabilities. The application running in container is absolutely safe. The application gets the complete dependency along with the main binary, and they will not impacted by the outside world. Any other issue in any of the machine will not impact this specific container. I mean to say, they are completely isolated. Now let's understand container in a much depth, and let's do a comparison also, the hypervisor versus container. Container does the same work as virtual machine or hypervisor. They serve the same purpose, but they do it totally in a different way. On left hand side there is a virtual machine using the hypervisor. On right hand side there is a container. With virtualization, both VM and container are eliminating the need of physical hardware. They are improving the efficiency of compute, and they help us in meeting the speed and the scale. As you can see on the right hand side, multiple containers are running on same machine and same host operating system. Well, the beauty is they don't need the separate guest operating system. The guest OS is there in the hypervisor. It's missing, or it's absolutely not there in the container. The containers share the kernel of host operating system with other containers. You can see all three containers, container 1, container 2, container 3. All these three containers are running in a very isolated way in their respective user space. There is a major architecture difference between the VM, hypervisor and container, and let's understand what are these differences. Let's understand how containers are different and what makes them very efficient and powerful. The first one is the guest operating system not required in container world. This is the biggest difference between the hypervisor and the container. In hypervisor, we need a guest operating system, and guest operating system is key to emulate the resource for the application. Well, in container world, the container use these resources from the host operating system. So it means it doesn't require a new guest OS out there. Since the new guest OS or operating system is not there in container world, the resource which were wasted in this guest operating system are now available. You can use these resources for application. You can see it on the screen. The application are using a much more resource pool, a bigger resource pool in containers as compared to the resource which are available in the hypervisor world. A better resource, the more resource available in container world makes us more powerful with container, wherein we can host multiple applications, more resources are consumed, and they are done in a very efficient way. So we can clearly tell hypervisor is wasting the resource in a guest operating system, and these resources are saved in the container world. The second biggest difference is the lightweight. Since there is no guest operating system in container, the host operating system is itself used. Well, there are only few additional library or dependencies which are required by container to work. This makes container very lightweight. You can see like the size of container is absolutely minimal. You can carry the container in like you can carry them in a pen drive, you can carry them in USB. They are easy to carry. They are smaller in size. They are lightweight. These 2 points make container fairly small in size as compared to the virtual machines. We have tried to show you this with the example of elephant versus mouse. Hypervisor based virtual machines represent the elephant, where mouse represents the smaller container. The next difference is the lightning fast speed. One of the other key benefit of container is the lightning fast speed. Containers are at least 9 times faster than virtual machines. They are created and destroyed in few seconds. We need not to boot up any additional operating system in container. Now this speed is really helpful in the situation where we need things on the fly. We need things to be happening really fast. You can see the example of tortoise and rabbit, where hypervisor represents the slow tortoise and the container represents the fast rabbit. Well, I am trying to give you a real life examples so that you can understand the concept in a better way, and then you can actually remember them for a longer time. The next difference is a virtualization mode. The VM virtualize the hardware. I mean to say the container virtualize the operating system instead of the hardware. So I'm repeating again. The VM virtualize the hardware, the container virtualize the operating system. Well, this makes the container much more portable and efficient. Since there is no OS based dependency in container, we have much better integration here. The containers are an abstraction of the application layer that packages the code and dependencies together. Well, the next point is the portability, and this is really the big point. Now let's put focus and attention to understand this. With help of Docker, which we are going to discuss next, the containers are so powerful. They are extremely portable. Anyone from the coder, the developer, they can develop these applications, the container based application in the lab. They can do the test in the lab, and the same code can then be ported. The same container code then can be ported to the public cloud, to the private cloud, to any production environment. The container is a world in itself. It ensures a seamless integration and migration of code to any type of platform. We also call container as like build once and run anywhere. I'm again iterating the same thing. Containers are a complete package. They contain both application and respective libraries, and they carry all their dependencies in this particular package. This package is going to run without any issue on any type of infrastructure. You can never achieve this type of portability with hypervisor or virtual machines due to all these dependencies which are coming due to the operating system. The next point is the modularity and the scalability. Dockers are used to scale in, scale out capacities, and they are done on a modular basis. This entire process is very automated, and this empowers the entire scalability thing. I mean to say, you can scale up the containers in a real fast way, and you can do it in a very modular way. Now that is something which is not available in the hypervisor world. Now let's understand what is this Docker. Docker is an essential tool designed to manage the container. Docker is directly responsible for creation, deployment, and running the applications which are based on the container. It is first released in 2013, and the Docker was developed by the organization by the name of Docker Inc. The Docker is used to run software packages called containers. Containers are created from the images that specify their precise content. The Docker images are often created by combining and modifying the standard images which are downloaded from the public repositories. Docker manages all of them. There are three main components for entire Docker to work. The first one is the build, the second one is the ship, the third one is the run. We are going to discuss all of these concepts in a much depth in my coming videos. So, we have completed our journey of the hypervisor versus container, and I am hopeful now you will be able to remember the difference between the hypervisor and container in a much better way. If you want to download this PPT or video, please visit my website. It's telecomtutorial.info. Hope this video presentation is useful for you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube channel for more technical videos. Thank you.